Welcome to Chemistry with Dr. Z. In this video, I will cover the topic of isomers. So what are isomers? Isomers are compounds which have the same molecular formula, but they can have different structures. So we have two main classes of isomers. We have the structural isomers, which are compounds which have the same molecular formula, but could they have completely different structure. And there are three types of these isomers: chain isomers, position isomers, and functional group isomers. And then we have the second class of isomers, which is the stereoisomers. And stereoisomers still have the same molecular formula. They have the same arrangement of the groups, have the same functional group, they have the same structure formula, but they have a different arrangement of the group in space relative to each other. So these include the E and Z isomers of alkenes, and also the isomers with the chiral center. So let's start off covering the structure isomers in more details. So the first type of structure formula is the chain formula. So these are compounds which have the same molecular formula, but the carbon chain connection is different. So basically, if we have something like C5H12, we could have pentane, we could have methyl butane, and we could have dimethyl propane. So as we can see, these are completely different compounds. The chain is different. The only difference between them is the connection of the chain, but they all have the same molecular formula, C5H12. So these are chain isomers. What about position isomers? Position isomers will have the same functional group, but the functional group will be at different carbon atom in the chain. For example, if we have C4H9Cl, we could have one chlorobutane, or we could have two chlorobutane. So we can see that the functional group here in the first one is on carbon number 1, but for the second compound it's on carbon number 2. So these are position isomers. They have the exact same functional group. The third one is functional group isomers. So they still have the same molecular formula, but they have different functional group. For example, C3H8O, it could be propanol, one propanol, and it could be methoxyethane. So we can see there is a completely different functional group. This is an alcohol and this is an ether. So they are completely different functional group and they will have completely different physical and chemical properties. So these are the structural isomers. What about the stereoisomers? Stereoisomers will have the same connections, will have the same functional group, but they will be arranged differently in space. So let's look at alkenes isomers. So the E and Z isomers of alkenes. We have here two different butene. These two are two butene. We have two butene, one, two, three, four carbon atoms in each, one, two, three, four carbon atom in each. So when you look at these two, both of them are two butene. Are they identical? Actually, these two are not identical. Isomers, alkene have isomers. The main reason for why alkene have isomers and why these two are not identical is because of the presence of the double bond. So the double bond will make the compound rigid and will not allow the movement of the atoms around the carbon bond. So because of the presence of the double bond, there is a restricted movement of the carbon atoms. So these different substituents will keep their position in space. They cannot flip to make the methyl group on the other side. So these two are completely different. So the first one, alkene, is called the cis 2-butene, or we call it Z2-butene. The second one is called the trans 2-butene, or E2-butene. So let's learn more about these isomers and how we can give it that prefix as Z or E. So there are two different possible isomers for alkenes, and these are called cis and trans, and we call it cis and trans only if we have 1,2 disubstituted ethenes. So if you have ethene like this and you only have two substituents on the two carbons, this we can call this cis or trans. But the more general name we use is the E and Z. So we use the E and Z naming. We're going to use a rule called CIP rule at each of the two carbon atoms, these carbon atoms of the double bond, to give priorities to the different group or different substituents. And based on the different groups which have the priority, whether they are on the same side or on opposite side, we're going to give it an E or Z. So for example, in this case, first case, we have the two groups, the R group, the two substituents here on the same side. So we're gonna call this Z because it's on the same side. But on the other isomer here, the two groups are on opposite sides. So we're gonna call it E isomer. So we either gonna call it Z or E. So let's establish the priority between the substituents so we can give the alkene the prefix either Z or E. So first thing you need to look at is to look at the atomic number of the atom directly attached to the carbon of the double bond. So the carbon which has the double bond, you have the two carbons. So let's say this is carbon 1 and this is carbon 2. So we look at carbon number 1 and the two substituents attached to it. And then we're going to arrange the two atoms attached to carbon number 1 based on the atomic number. And based on the atomic number, as we can see it from the periodic table, if you have a chloro substituent, it's going to be has priority over the fluoro, which is going to have priority over oxygen, which is more than nitrogen, more than carbon, and more than hydrogen. So let's say you have a fluoro here and you have a hydrogen here, then the fluoro is going to take priority. Now, if the same priority at the first atom, we need to go the first point of difference. So what do we mean by this? So let's say we have two different substituents on the same carbon. And the first one is the ethyl, and the second one is this substituent, which is isopropyl, or we can call it 2-propyl. So which one will take priority? So the first atom, or the first atom of that is connected to the double bond, is carbon. And then we look at this carbon. What are the different atoms attached to it? So this carbon here on the left has two hydrogens and one carbon, but this one on the right has one hydrogen and two carbons. So this one takes priority because the carbon takes priority over the hydrogen that we can find here, because here there are two hydrogens, but here we only have one hydrogen. So this is the first point of difference, and this is going to be the one that will take the priority. So for example, if we have here CH2, CH3, and here the carbon, and then the hydrogen CH3 and CH3, then this is gonna take the priority. Look, now we have the two groups which have the priority on the same side. So this is going to be a Z isomer. So this is going to be a Z isomer. We're gonna give it the prefix Z. Let's have another example of how to give the priority. So we have these two here, and then we're going to see that these two groups are attached to the same carbon. So the first attachment, both of them are CH2, so exactly the same. Second one is CH2. The third atom is sulfur for both. And then the fourth atom here it's hydrogen, but here it's a carbon. So this one will take the priority. So if you have these two groups attached to the same carbon, this one is going to take priority. Another example, if we have something like that, so again, you might be tempted to say that this one takes priority because of the presence of the OH, but you are not following the rule here. So we need to look at the first point of difference. So let's look now. So the first attachment here is carbon here and carbon here. And then this carbon is attached to two hydrogens and one carbon, but this one has one hydrogen and two carbons. So this is the first point of difference, this carbon atom with this hydrogen atom. So this group is going to take the priority over the other one because we already established the priority before we reach the oxygen. So this one takes priority over that one. Let's have some examples. So if we have something like that, so we said we're going to have the two butene isomers. So this is the first butene. We have the first carbon to the left, the yellow one. We have hydrogen and methyl. Of course, methyl is going to take priority. So this is going to be number one on the the left hand side. On the right hand side, we also have methyl and hydrogen. Methyl is going to take the priority. So this is going to be number one in the priority. So for these two on the same side, it's going to be Z. The other isomer, now carbon on the left, the yellow one, methyl takes priority. Carbon number two on the left, we're going to find the methyl on the right, sorry, the red one on the right. The methyl is going to take priority over the hydrogen. So this is number one. They are on opposite sides. So this is an E isomer. Another example, so now we have the two carbons here with the double bond. Let's have a look at the one to the left first. We have chloro and bromo. Bromo will take priority, so this is number one. Here we have hydrogen and methyl. Methyl will take priority, so this is number one. The two groups which have the priority are on opposite side, so this is an E isomer. Be careful when you give the priority that sometimes you have the two substituents are exactly the same. So no one takes priority over the other. For example, we have the double bond here. If we look at the left here, we have hydrogen and we have an isopropyl or two propyl group. This will take priority. But when we look at the carbon atom to the right, we're going to find that we have the exact same substituent. So these two are exactly the same. So there is no priority here. And if there is no priority, then there is no isomers. So it's not Z or E. So there is no isomers for this particular alkene. So you need to be careful and you need to assign the priority. If the two groups on the same carbon are exactly the same, then there is no isomer, there is no Z or E isomer. The second type of the stereoisomers is the isomers with chiral center. So a chiral center is a carbon atom which has four different substituents attached to it. So if you have a carbon atom that has like methyl, ethyl, and an OH and a chloro group, a chloride or a chloro, then this is a chiral center. This is a carbon atom that has four different substituents attached to it. It's called a chiral center. For these compounds, they will have an mirror image to it. So it will have another compound that have the same substituents, but it's going to be the mirror image of this compound. And when you draw the mirror image, you're going to have this carbon, then it's going to be the ethyl group on that side, the methyl here, the OH here, and the chloro here. So these two are mirror image to each other, as you can see, and these two are different and they are called enantiomers. So important rule that the center of chirality must be a carbon atom with four different substituents. So this is an example of two enantiomer of the compounds. And then we have the center of chirality, this carbon atom, which has four different substituents. These enantiomers will have the same chemical properties because they have the exact same functional group, but they also going to have the same physical properties. So something like melting point, spectroscopic properties, all of the physical properties are going to be the same, but they are still different compounds. They are mirror image to each other and they are not identical. How can we name these isomers? We also use a prefix for these isomers, which are R or S. So let's have a look how to differentiate between these by labeling them using the prefix R or S. So we're going to give priority to the four different groups. And when we assign the priority, we're going to assign the priority 1, 2, 3, 4, following the same rules for the assigning priorities when we were talking about the isomers of the alkenes. So now we need to assign the priorities for this compound. We have an OH, methyl, carboxylic acid group, and hydrogen. So the one what's going to have the highest priority is the OH because the oxygen will take priority over the carbon and here the carbon and the hydrogen. So this is number one. Number two is going to be the carboxylic acid group. This is going to be number two because here we have the carbon and attached to it there is an oxygen. Here we have a carbon attached to it. There are three hydrogens. So this is going to be the take the priority number two. And then methyl, we're going to take priority over the hydrogen, which is going to be number four. Now we need to look at the three groups, which we gave them priority as one, two, three, and look how they go from one to two to three. When we do the arrangement, do they go clockwise or anti-clockwise? In this case, you're going to see that one, two, and then three. This goes clockwise. If it goes clockwise, we're going to give it the prefix R. If it goes anti-clockwise, then we're going to give it the S. So let's go back to this example, these two. So now we have the two mirror image, the two enantiomers. Which one is going to be the Z and which one is going to be the R, which one is going to be the S. So we know now the priority, OH number one, carboxylic acid group two, the methyl 3 and hydrogen 4. In this case, from 1 to 2 to 3, it goes this way, which is anti-clockwise. So this is the S isomer. And for this one, we have OH here, carboxylic acid 2, methyl 3, hydrogen 4, and it goes this way, which is clockwise. So this is the R. So this is how to distinguish between the R and S isomers.